Hey guys, welcome to another episode of my channel. So if you are following this series, you know that I have created episode about connecting your ESP microcontroller to local Wi-Fi. Then in next episode I showed you how to create a simple client-server communication with ESP microcontroller as client and the Python server, where there is only single instruction that should be transmitted from server to client to be executed. And in that system there is a single ESP microcontroller and single server. But in my previous episode I showed you how to create system that would have multiple ESP microcontrollers communicating with single server continuously. And on the left side you have code for server from our previous episode, but code for ESP it's a little bit modified. So what is the plan for today's episode? I want to make one step further and I want to show you how to upgrade this system in order to include your Android phone. So at the end of this episode I'm going to be able to use my own phone to transmit instructions to my Python server, and then server is going to distribute those instructions to microcontrollers. Or in this particular case I'm going to use only one ESP8266 microcontroller, but you could hook up many more if you want to. And how exactly that is going to look like. So as you know, in our previous episode I used my ESP8266 microcontroller with single LED diode. Now I have connected another LED diode. So what I have in here, you remember that I have connected red diode to my D5 pin on ESP8266 microcontroller. But now I have connected another one to D6 and I name it Light 2. Then I set pin mode for light 2 to output, and we set default value to low. And at the bottom of this code, let me show you what I did in here. So now we are actually reading 2 bytes. And I'm going to remove these 3 printing statements. Those are completely unnecessary. So with client read bytes, we are reading instructions from our server. And then if first byte is set to 1, we are going to send low to our red diode. If it's set to 2, we are going to set it high to red diode. And then we are checking second byte. If that byte is set to 1, we are going to send low to our yellow diode. But if our second byte is actually set to 2, we are going to turn on that diode. And I've already uploaded the code for my microcontroller, so there is no need to do that. And now I'm going to upgrade code for our server. So as you know from our previous episode, first we are creating communication socket. Then we are creating address and we are binding that address to our socket. Then we are starting with listening. And with this while loop, we are accepting incoming connections. When connection is established, we are passing that connection to our communication thread. And we are starting that thread. And in here, what is happening? First, we are receiving a message from our microcontroller. And that message contains just a word hey. And I'm going to change this to 128. We could use even smaller number, but doesn't matter for now. So when that message is received, we are decoding it and we are checking if that message contains stop. That is actually killing command. So we are closing socket and we are exiting our server. But if that message doesn't contain stop, we are creating a message that contains number 5 in binary form, and we are sending that message. And now I'm going to make those changes I promised. So first thing that I want to do, I want to include more libraries. So from multiprocessing, shared C type, import synchronized. And we need this in order to use a locking mechanism. And now after socket is created, I want to create message in here, and that message is going to be in binary form with X01 and X01, and that means that by default both diodes are going to be off. Now we are going to initialize our lock, threading, lock. Now in here we are going to pass address, and I'm just going to change that part. So now we are not only passing connection, we are passing address too. And self ADDR is going to be ADDR. In run, first thing that we are going to do, we are going to create global message, and I'm actually going to change this to 10. This part is okay, this part is also okay, but now I'm going to use elif statement. If received contains, I'm going to check for string ins, that is short for instructions, column, and let's deal with this case. I'm just going to remove that initial string, and I'm going to replace it with empty string. So basically with Android phone, what we are going to do, when we are sending instructions, we are going to send initial string ins, and then we are going to append two numbers. 0 means turn off and 1 means turn on. And first number is going to deal with red diode, and second number is going to deal with yellow diode. And in here I am going to create 2 bytes, just 0 bytes, like this. And now if received, first number it's 0, we are going to set A to 1. Else A is going to be set to 2, and I need column in here. I'm going to copy this code to deal with second byte, like this, and instead of A we are going to use B. Now I'm going to exit from this if statement, and I'm going to acquire lock, and I'm going to deal with our message freely now, and our message is going to contain A plus B, like this. And I'm going to release this lock. Now after all of that, we are going to copy this piece of code because it's much easier. All right, I'm going to create another variable that is going to hold content of our message. This is unnecessary, and I'm going to send that message to our microcontroller, and I'm going to print something to the screen. Let's say formatted message column, and that is going to be mess sent to ADDR. All right, connection close, it's totally fine, but I need to say self ADDR. Okay, now it's much better, and I would say that our server code is done. Okay, I'm going to save this code, and now we are going to deal with our Android code. So open your Android Studio and create a new project. I named my project ESP8266 client. And definitely first thing that you should take care, it's open your Android manifest and include these 2 user permissions. So in order to use socket with Android, you need Android permission internet and access network state. When that is done, close this, open activity main, And in here, create two text views, a red diode and yellow diode. So what I want in here, I want when my app starts to retrieve states of diode from the server. And if red diode is on, I want background for this text view to be red. If it's off, I want this background to be gray. With yellow diode, if it's on, I want background to be yellow, and if it's off, I want to be gray too. And let me show you the code in here. The only thing that you should know in here is that ID is red diode for red diode text and yellow diode for yellow diode text. So if that is clear, I'm going to open my activity where we are going to write our code. So first thing that we should do in here is to create 4 global variables, 2 text views, like this, and 2 Boolean variables, red and yellow. So these 2 Boolean variables are going to hold states for our diodes, and by default those states are going to be set to false, like this. And in here we are going to reference our text views, so red diode, RID red diode, and yellow diode, RID yellow diode, like this. Now I'm just going to create on-click listeners for these 2 diodes. Set on-click listener, new on-click listener. Alright, and first thing in here we are going to reverse value for our red boolean, and we are going to call function send inc for send instructions, and later on we are going to write code for this function. So what is happening in here? Whenever we click on red diode button, we are going to reverse state for our red boolean. So that means if our diode is on, it's going to be off. If it's off, it's going to be turned on. And then with this function, we are going to send instructions to our server. We are going to do the same for yellow diode, like this. I'm just going to change boolean. All right, everything else is the same. And now we have to create on start void from override methods. Okay, on start, and in here we are going to call function communicate, like this, with empty string as argument. And now we are going to create code for this communicate function. That function is going to be executed first when our application starts. All right, so private void communicate and final string inc instructions. All right, and this entire function is going to hold thread, new thread, new runnable, and we are going to start that thread immediately. So we need this thread because in Android you must have separate thread for socket communication. And first thing in here we are going to create socket in order to connect to our server. Socket, new socket, we are going to provide IP 24, it's IP on my PC for port 47828. Alright, I guess that port number is fine. Okay, what we need is input stream in, or call it yes, socket get input stream, and we need output stream. Output stream OS socket get output stream. All right, and now we need try catch statements. All right, and put everything inside. I'm going to put socket declaration inside too. It's much better. And now we are going to check this string, what it contains. So if I'm going to name it INS. For instructions contains INS, we are going to create byte array from that string, and we are going to send that package to our server. Write data 0 data length. All right, and we are going to flush our socket. Now else I'm going to copy these 3 lines, and I'm just going to change INS to hey, like this. So when we provide empty string to our communicate function, this thread is going to send text hey to our server. After this part is done, we are going to create byte array, call it R, with only 2 bytes, that is going to hold package that we are going to receive from our server. And now input string read to R from 0 to bytes, like this. And now we are going to call function set background color, like this, and we are going to provide R to it. And in a moment we are going to deal with code for this function, but for now communication function it's done. Okay, but before we do this set background color function, I want to do code for this send instruction function. All right, also private void send INS, no arguments. First I'm going to create string, let's call it com, it's going to be empty string. And now if red boolean is true, I want to set com to 1. Now else com is going to contain 0, and I'm going to copy these 4 lines for yellow diode. But in case of yellow diode, we need to append this second number to first one, because you know we have to send 2 numbers, one for red and another for yellow diode. And at the end of this function we are going to call function communicate, and we are going to send INS as prefix, and we are going to send these 2 numbers. And finally we are going to set background colors. Okay, so also private void and we are accepting byte array as argument, like this, or better call it colors, like this. And now, because we are dealing with interface of our app, we have to do this by calling run on UI thread. All right. Because as you see, we are calling this function once from our separated thread, and in Android that is not going to work. Okay, so if colors first element it's 1, our red diode set background color, and we are going to create color RGB. All right, so alpha is going to be 255. For gray color we are going to set values 200 each. All right, and I'm going to copy this part. Else red diode set background color. I'm going to paste this, and now I'm just going to change these two values. So for red color it's going to be 200 00, but we need another line. I forgot about that. Going to correct that part. Just put another pair of squirrely brackets, because in here we have to set Boolean values. Red is going to be set to false, and in here red is going to be set to true. This section is actually not necessary for button click event, but it's important to have this code during application start to set initial values. And now I'm going to copy this statement, this entire statement, just for yellow diode. All right, now we are dealing with second element, and we are just going to change all of this to yellow. Yellow diode set background to gray, and change this to yellow. All right, yellow. But now our second argument, third argument, is going to be 202, because in that way we are going to get yellow color. And in here yellow set to true. So guys, this code is totally okay. Next part of this tutorial I'm going to record with my camera, so you could see actual real life example. So guys, now you can see that our server is up and running, and we are constantly sending message 11. That means that both diodes should be off. And as you can see with my little setup, both red and yellow diode are off. But now on my right side, you're going to see that I'm running Android app we just built. And now I'm going to click on red diode. And red diode it's on. Now on yellow, and yellow it's on. Turn it off. Red first, and then yellow. So our example is working. And now we are going to get back to our code in order for me to explain a few more things. So guys, now final words for this tutorial. First thing that you should keep in mind is that this tutorial covers only basic principles of how this works. There are so many things that you should take care of when you are building a system like this. But this tutorial will definitely be excellent starting point if you want to get yourself into this subject. Second, I want to direct your attention towards certain mistake I made. On side of our microcontroller, we are receiving 2 bytes from the server. And first byte is going to determine state of our red diode, and the second byte is going to determine state of our yellow diode. And if you take a look into this code, if we receive 0, 1, our diode is going to be off. But if we receive anything else but 0, 1, we are going to turn our diode on. And on side of our server, we are receiving also 2 bytes from control unit, which is in this case my phone. But in here, if we receive 0, we are going to send 0, 1 to microcontroller. But if we receive 1 from control unit, we are going to send 0, 2 to microcontroller. But still we ended with working code. So you could say that our project is successful by accident. And maybe there is a little bit of that. Because when you are making system like this, using different command codes on different instances on your system could easily become source of error, so be very careful about this. But at the end, if you get yourself into computer software career, you are going to see that only thing that is important is that you have a working code. Because in most of cases, your boss is not going to be software engineer. Your client too would not know how this actually works. And your colleagues would probably have more than enough problems of their own. So you are actually good to go. So guys, thank you for watching. I hope that you have learned something interesting. So please like, subscribe, and see ya!